So today we're going to look at describing data. We're going to look at several different ways to display data. First thing we're going to look at is called a frequency table. The table with two columns. One column lists the categories, and the other for the frequencies with which the items in the categories occur. In other words, how many times items fit into each category. First, this is actually interesting. Insurance company determines vehicle insurance premiums based on known risk factors. If a person is considered a higher risk, their premiums will be higher. One potential factor is the color of your car. The insurance company believes that people with some color cars are more likely to get in accidents. To research this, they examine police reports for recent total loss collisions. Data is summarized in a frequency table below. Now, the data they're using here is real data. It's not just made up. So it's kind of interesting that you would think black would be the worst one. Or red, yeah. Well, depends on what kind of accidents we're talking about. The interesting thing here is green. Green is the worst. Seems surprising, but I have a green car. And I drive about 60 miles to get here. And fortunately, most of it's on the interstate. But when I drive through town, just a little bit of town driving I do to get here, I probably get close to being hit 3 times each time I come out here. And the reason is my green car blends in with the trees on the side of the road. People don't see me. But it's kind of bizarre. Yeah, you would think, like I said, black. Of course, my sister-in-law's truck is black and she's been hit 3 times. I've only been hit once. So another way to display data is with a bar graph. Bar graph is a graph that displays a bar for each category. Here we're still talking about qualitative data. And the length of the bar indicating the frequency. So here's our data again in a different format. We have a vehicle color here, and then the frequency, they were in accidents there. Here we have another chart called a Pareto chart. This is a bar graph ordered from highest to lowest frequency. Again, the same information, just in a different format. Now, here we have in a survey, adults were asked whether they personally worried about a variety of environmental concerns. The numbers out of 1,012 surveyed who indicated that they were worried a great deal about some selected concerns are summarized below. So here we have our frequency table, and then here we have our bar graph. And it's actually a Pareto bar graph, as it is from largest to smallest. Just different ways to show the data. And we're still talking qualitative, even though technically those are numbers. Another method, I'm sure you've seen these, pie chart. The circle with wedges cut of varying sizes, marked out like slices of pie or pizza, always with food. The relative sizes of the wedges correspond to the relative frequencies of the category. So again, here is our car data. Pie charts can often benefit from including frequencies, which we've done here, or even percentages. Often having the category names next to the pie slices also makes the chart clearer. So again, another pie chart. Pie chart below shows the percentage of voters supporting each candidate running for a local seat. If there are 20,000 votes, did you bring enough for everybody? Yeah, must have something going on out there. If there are 20,000 voters in the district, the pie chart shows that about 11% of those 20, or about 2,200 voters support Reeves. Again, another way to display data. You might include the frequency, you might include the percentage. And ideally, your chart, your sizes are in relation to the percentages. Another method we use to show data is called a pictogram. Pictogram is a statistical graphic in which the size of the picture is intended to represent the frequencies or size of the values being represented. So a labor union might produce the graph to the right to show the difference between average manager salary and average worker salary. Looking at the pictures, it would be reasonable to guess that the manager salary is 4 times larger than the worker salary. The area of the bag looks about 4 times as large. However, it's not about the area, it's about the height. So in this chart, managers make twice as much. But it looks like 4 times as much, depending on how you look at it. That's one of the ways we have to be careful when we're using these charts and graphs. And here's another example. So compare the 2 graphs below showing support for same-sex marriage rights from a poll taken in December of 2008. The difference in the vertical scale on the first graph suggests a different story than the true differences in percentages. The second graph makes it look like twice as many people oppose marriage rights as support it. So the way we show the information can affect, because this is the same information, but it sure looks like a whole lot more opposed than support in the second one. Whereas here they look almost equal. So that's something you have to watch for when looking at this type of information in these kind of formats and when putting the information into these type of formats. It's very easy. What's the old saying? Statistics don't lie, but statisticians do. Well, it's not the statistician, it's usually the politician. So here we're going to do a frequency table for these data points. Teacher records scores on a 20-point quiz for 30 students in his class. And here's a list of scores. Let's summarize these results in a frequency table by grouping like values. So we start out with 0. And then 1, 2 zeros. And then 1, is that it? 1, 5? About 12. 1, and then 15, 1, 2, 2, and then 16, 1, 2, 17, 1, 2, 3, 4, 18, 1, 2, 3, 4, 5, 6, 7, 8. 19, 1, 2, 3, 4, and 20, 1, 2, 3, 4, 5, 6. So to make sure we got them all, just add this up. 2, 3, 4, 6, 8, 12, 20, 24, 30. So they're all there. That's our frequency. Everybody follow how we did that? We just counted how many times each thing showed up. The bar chart would look like this. This is not a histogram. This is a histogram. So since the scores are numerical values, this chart doesn't really make sense. The first and second bars are 5 values apart, while the later bars are only 1 value apart. It would be more correct to treat the horizontal axis as a number line. This type of graph is called a histogram. Histogram is a bar graph where the horizontal axis is a number line. So for our previous thing, we look at something like this, where the values that don't have anything, we have no bar, but it's a continuous value. It's a number line. So that brings us to class intervals. Groupings of data in general, we define class intervals so that each interval is equal in size. For example, if the first class contains values 120 to 129, the second class would be 130 to 139. Ideally, we have somewhere between 5 and 20 classes, depending on the number of data you're working with. If you only have 10 data points, you're not going to want to have 20 classes. It wouldn't work. So suppose that we've collected weights for 100 male subjects as part of a nutrition study. For our weight data, we have values ranging from as low as 121 pounds to as high of 263, given a total span of 142. And we could create 7 intervals with a width of around 20, 14 intervals with a width of around 10, or somewhere in between. Sometimes we have to experiment with a few possibilities to find something that represents the data well. So here we used an interval width of 15. Now we could start at 121 because that's the lowest weight, but why not start with 120 so we have a nice round number? Makes the math easier too. So this is what the frequency interval will look like for that data. And then the histogram. So the big difference between a bar chart and a histogram is typically if you have no values that have a frequency of 0, your histogram is going to be connected. There's no space in between the bars. Whereas a bar chart, there is space between the bars. Any questions so far? So the data below came from a task in which the goal is to move a computer mouse to a target on the screen as fast as possible. On 20 of the trials, the target was a small rectangle. On the other 20, target was a large rectangle. The time to reach the target was recorded on each trial, and then we put it into a frequency table. Here we have 2 trials, small target, large target, large target. Another way to represent this would be a comparative histogram or bar chart, which the bars for the small target group and large target group are placed next to each other, such as this. Note they're different colors and we label them by color. So this is one way to compare 2 sets of data. That brings us to frequency polygon. Another alternative representation is the frequency polygon. Frequency polygon starts out like a histogram, but instead of drawing a bar at a point is placed in the midpoint of each interval. At height equal to the frequency, typically the points are connected with straight lines to emphasize the distribution. So looking at this, kind of hard to really see anything. Looking at this, it makes a whole lot more sense. It's easier to see the comparison of the two, which is why we did both, to do the comparison. So any questions on frequency polygon? Essentially, I'm sorry? Because when we go back to the previous page, there was nothing here. So we needed to start, we want to start before this just to make it easier on us. So at 350 to 400, there's 0, which is right here. That's the midpoint between 300 and 400. And then we go to the midpoint here, and we have our 2 dots. And same here. See, we're putting a dot instead of, in the histogram, we would put a bar like that. But comparing 2 data, this is kind of hard to really see what's happening. This is a little easier. Okay? Any other questions? So now we can do some quantitative data. First thing we're going to learn is called the mean, also called the arithmetic mean of a set of data is the sum of the data values divided by the number of values. In other words, there's a dirty word in statistics called average. The mean is the average. So in formula, the mean is referred to as mu. If we're using a population. And it's referred to as X with a bar over it, or X bar, if it's a sample. That's the first thing. The formula to calculate the mean, either way really, is the sum of all the data values, sum of X divided by N. X is the data value, N is the number of data values. So what this means is I add up all the data values. X bar is calculated the exact same way. Now, one of these formulas at least will be on the test if you need it. You will be given your formulas for the exam. Any formula you need will be there for you. I think I put them on the last page. So to find the mean of this group of data, I simply add all 4 of them together. $79 plus 86 plus 82 plus 94 equals 341. And then there's what, 4 data values. So this is my sum of X's. N equals 4. So I'm guessing this is a sample, so we'll call it X bar, which is the sum of X over N, which is 341 divided by 4. 85.25. Please give me some decimal places, at least 1 or 2. Any questions on the mean? or how to calculate it. Let's look at another example here. So the number of touchdown passes thrown by each of the 31 teams in the National Football League in the 2000 season are shown below. Find the average or mean of the touchdown pass. Technically, this would be the population since there's only 31. So mu equals the sum of all my x's over, and it tells me 31. Well, n. So the sum of x's and n equals 31. So now we need to add them all up. $37, $33, $3, $32, $29, $28, $28, $23, $22, $22, $22, $21, $21, $21. That doesn't seem like a whole lot of touchdowns, does it? Four times 16 plus 15 plus 14 plus 3 plus 12 plus 12 plus 9 plus 6. I get 634. Divided by n, which is 31. And we get 20.4 pounds. So again, it's add them all up, divide by how many they are, and that is your mean / average. Any questions? Okay, so here we have 100 families in a particular neighborhood ask their annual household income to the nearest $5,000. The results are summarized in a frequency table below. Find the mean. So now, what does this mean? Well, first of all, n equals 100. Now, families that had 15,000 income, there was 6 of them. Now, to calculate the mean, I have to add it up. I have to add them all up. So I could do this. And do that for every level. Or isn't that the same as saying 15 times 6? And then this is 20 times 8. And this is 25 times 11. 275. 17 times, or 30 times 17. 510. 19 times 35. Or 35 times 19. Is that 700 minus 35 or 665? Here we have 40 times 20. 800. Here I have 12 times 45 or 45 times 12. Is that 450 plus 90? 540. And then 50 times 7, which is 350. Now I need to add those totals here up. $90 plus 160 plus 275 plus 510 plus 665 plus 800 plus 540 plus 350. That gives me a total of 3390. So n is 100. sum of x equal to 3390. My mean is the sum of all x's over n is 3390 over 100, which is 33.9. That is my mean income. Everybody follow that question? Everybody good? Ready to move on, or you need more time? Everybody got it? Yes? Yes? So, extending off the last example, suppose a new family moves into the neighborhood that has a household income of 5 million, which is 5,000 thousands. Add this to our sample and calculate the new mean. So the old one had n is 100. Sum of x's was 3390. Mu was 33.9. Now the new one, we're adding one more person, so n equals 101. Okay? Everybody good? So looking at my sum of x's, I had 3,390. I'm adding 5,000. Now I have 8,390. That's my new sum of x's. So now to find my mean, remember it's the sum of all the x's over n, which is 8390 over 101. I guess that's Bill Gates that moved into the neighborhood. I added one to the previous example. Yeah, remember, this is what it was. On number 16. These are the results from number 16. We added one more family. So we had 100, we added one, so now we have 101. Then we added 5,000 thousands. So from 3390 to 8390. Okay. And then we do our division here. And I get a mean of 83.07. And see how much difference it makes just with one person, way outside the average. So again, any questions? What's next? Next, we have the median. The median of a set of data is the value in the middle when the data is in order. To find the median, begin by listing the data in order from smallest to largest or largest to smallest. I recommend going smallest to largest because later on we're going to need it in that order anyways. If the number of data values, n, is odd, then the median is the middle data value that can be found by rounding n divided by 2 up to the next whole number. If the number of data values is even, there is no middle value. So we find the mean of the two middle values, which is n divided by 2 and n divided by 2 plus 1. So let's go back to our touchdown data. Again, we have 31 data points. And we have them listed in descending order, which is okay right now. So n equals 31. It's odd. So we take n divided by 2, 31 divided by 2, which is 15.5. Since it's odd, we round up to 16. What this number here is is counting from the beginning, count to the 16th data point. So we're looking for data point 16. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. So the median is 20. That wasn't too rough, was it? Okay, so find the median of these test scores or quiz scores. So first thing we need to do is put, excuse me, put it from smallest to largest. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So n equals 10. Start with the smallest, which is 2. Then what? 4, 5, 6. Oh, there's 2 5s. Then 6. Then there's 2 7s, 2 8s, and a 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So remember it said take n divided by 2, which is 10 divided by 2, which equals 5. Then we take n divided by 2 plus 1. 10 divided by 2 plus 1. 5 plus 1 is 6. 5 plus 1 equals 6. Okay? So what this means is my median is equal to the 5th data point plus the 6th data point divided by 2. So here's the 5th one. 1, 2, 3, 4, 5. And that makes this the 6th one. I have 6 plus 7 divided by 2. 13 divided by 2, or 6.5. 6.5 would lay right here if I had a value. So the interesting thing about the median is it splits the data into 2 equal parts. So if my median is here, I have 1, 2, 3, 4, 5 data points, 1, 2, 3, 4, 5 data points. Up here, we counted these to 15. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So the median splits the data in half. On either side of it is half the data, if put in numerical order. So what about with a frequency table? We have 100 data values. We could find it by adding the frequencies if we didn't know. We need to find the mean of the middle 2 data values, which is the 50th and the 51st. And how do I find that? Well, again, we're smallest to largest, right? The first 6 values are right there. The next 8 values are here. So that's 6 plus 8 is 14. So to here is the first 14 values. That makes sense? Now the next 11 are here. So that's 14 plus 11, which is 25. So to this point, I have 25 data values. Then I have 17. So I have 25 plus 17, which is 42. Now I have my first 42 data points. And here I have 19, 42 plus 19 equals 61. So at this point, I have 61 data points. At this point, I have 42. So what is the value for the 50th data point? Now, if the 42nd one is in here, and this goes all the way to the 61st, isn't the 50th value in here? This isn't at 43, 43rd, 44th, 45th, and so forth. I see some blanks there. To this point, I have 42 data points, up to the 42nd point. I need the 50th point. Now, once I get here, at the end of this, I'm at the 61st data point. So essentially, in this bracket here, and the 43rd, 44th, 45th, 46th, 47th, 48th, 49th, 50, 51, 52, all the way to 61. Right? Because at this point, it's 42, and at this point, it's 61. How many data points I've accounted for? Is it clearing anymore? So, both the 50 and 51st are in that value. So I need to add the 50th, which is 19, and the 51st, which is also 19, divide by 2, and I get 19. Or not 19, 35, sorry. Because this is how often, this is how much. So it'd be 35 plus 35 divided by 2, which is 35. That would be the median income. Okay? Any questions? This would be the last one today. Now we got one more, sorry. The mode is the element of the data set that occurs most frequently, or most frequently. So going back to our vehicle color survey, going back to, this is a different one. We collected the following data. Identify the mode. What color appears the most? This is the frequency, how often it appears. So which color has the highest frequency? Green. Maybe that's why it's in the most accidents. It is possible for data set to have more than one mode, if several categories have the same frequency, or no modes if each category occurs only once. So what about this? Is there a mode here? I don't see any repeats, so please on an exam, if the question doesn't have a mode, please make the statement no mode, do not leave it blank. This is the last thing we're going to talk about today. The range is the difference between the maximum value and the minimum value of the data set. So consider the following quiz score, find the range. So what's the maximum value? 98. What's the minimum value? 71. So our range is 27. And then looking at these salaries, our highest value is 48,800. Lowest is 28,500. To find the range, we subtract and we get 20,300. So, any questions on anything we've covered today? The main thing you'll want to make sure you can do is the mean, the median, and the mode. All the different ways to display the data, that's for informational purposes. There are no tests on that. Again, use the homework to determine what you need to study. So any questions at this point? Everybody's good? Okay. So let's stop this recording.